Hello guys, welcome back to my channel Algorithm Minds. My name is Hasan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concepts as well as practical programming skills in data science, data analysis, statistical analysis or machine learning. So if you are a person who wants to learn Python programming, MATLAB or even R programming from scratch, or you are a person who wants to excel his career in data science, I request you to subscribe to my channel and hit the notification bell icon button. As I stated earlier that I am going to produce a series of video on the topic statistical analysis in Python. So today I'm going to discuss one of its topic, which is skewness and variance using Python. So in this tutorial I'm going to briefly touch over the theoretical aspect of skewness, and then later on we will jump towards the practical aspect of practical programming section, where I will actually teach you how to actually generate data that has been positively skewed, negatively skewed. Then I will also teach you how you can actually graphically visualize those results. So let's move on and actually discuss a brief about what is skewness and with regard to our data sets. So skewness measures the asymmetry of the probability distribution of the real value random variable about its mean. It tells us whether the data is skewed to the left or right, or it is symmetrically distributed. Skewness can be positive, negative or even zero. So there are two types of skewness: positively skewed and negatively skewed. So in positively skewed, the tail of the distribution is longer on the right side and the bulk of the observations are concentrated on the left side. So this is the example of positively skewed distribution, where the bulk of the data is actually on the left side, where the tail is actually on the right side. Then we have negatively skewed data. The tail of the distribution is longer on the left side and the bulk of the observations are concentrated on the right side. So it means that for negatively skewed data, whatever the distribution we have or whatever the data points do we have, most of the distribution or data points will lie towards the right side of the distribution, while less will lie towards the left side of the distribution. So example of negatively skewed data set is such that we have like income distribution, where high earners pull the mean upward. We have like exam scores, where a few low scores affects the mean. In negatively skewed data, the mean is typically less than the median. So if you recall that mean is the average value, that is some value of all data points that are present and divided by the total number of data points. Mean is that, okay? So that's a brief introduction about the skewness. And let's move on and actually jump towards the practical programming sections. So the first step in any practical programming section is actually to import the important libraries. So we have, in order to execute our code, we are going to import some number of libraries for this task here. First of all, I'm going to import NumPy. By using this Python statement, import NumPy as NumP, as NP is an alias. That is, whenever we want to actually call the NumPy library, we will call it by NP instead of NumPy. Then we are also going to import pandas, so we will use import pandas as PD. Then for the plotting purpose, we are going to import two libraries. First one is actually Matplotlib and its module pyplot, as we will import it as PLT. Then we are also going to import cbond as SNS. So once we have actually imported our data, imported libraries, let's move on and actually work on actually creating the distribution that is actually positively skewed, negatively skewed, or that has no skew at all. So this purpose, I'm going to first call this function method here, np_random.seed is equal to 0. This line of code or the Python statement actually help us ensure that whenever the code has been executed again and again or at different places on different computer, it will produce the same result regardless, same random distributions regardless of how many times the code is run. So it is useful for reproducibility. So now you understand the purpose of this np_random_seed equal to 0. Input argument as 0. Then let's move on and actually create our first data, which is the positively skewed data. For this purpose, I'm going to use a NumPy method random and its NumPy library and its module random, and then I'm going to call the function exponential. And within those exponential, I'm going to pass two input arguments. The first one is actually scale, and the second one is actually the size. So size will define how scale will define the rate of decrease of the data, and size will define how many data points you actually want in that distribution. In our case, we want 1000 data points for that exponential distribution. So in this way, we will be able to get a positively skewed data that where the major of the values are actually present at the left side of the data. And once we have actually done that by using this line of Python code, then we can simply produce the results for negatively skewed data by negating the positively skewed data. So in that case, it will be the inverse of the positively skewed data. Therefore, you can see that we have actually used minus sign here. Now in order to create data that is randomly distributed and that has no skew at all, so for this purpose we are going to use the Gaussian distribution, which is also known as normal distribution, and I'm going to use the method normal. And you see I'm passing 3 input argument. Log is equal to 0, scale is equal to 1, and size is equal to 1000. For the last input argument 1000, understand the concept. It's related to how many data points I actually want to generate. Now coming back to log and scale, so the log here is equal to 0, it signifies that the normal distribution will have a mean of 0, and scale is equal to 1. It determines that the standard deviation of the normally distributed data points that we are getting out of this function will have a standard deviation of 1. So that's what it means by we are using 3 input argument. So let me run this block of code for you. Now we have happily generated our data for positively skewed distribution, negatively skewed distribution by negating the positively skewed distribution, and finally we also created a data set with random distribution that has no skewness at all. So once we have generated a data set, let's move on and actually calculate the variance of that distribution and also the skewness of that distribution. And it is quite easy to do that by the use of Pandas library, and I'm going to teach you how we can actually do that. So before we can actually calculate those variance and series, let's just create a dictionary that will store all those distributions. And if you remember that a dictionary where we actually store by key value pair, so if we want to access any value out of a dictionary, we will use key value. And for the same purpose, the reason why actually creating a dictionary, because we want to actually extract the values by using their key or the specific reference. For example, if we want to get the positively skewed data, we will use this key here, positive skewed. And for negative, we are going to use a key negative skew that has a value of the distribution that is negatively skewed, and the same goes on for no skew at all. So that's how we actually created a dictionary. We initialize a variable named dataset, then we created a dictionary by defining key value pairs within those curly braces and separating those values by the use of comma. So those of you who actually don't have an idea about how to create dictionary, I have a very highly resourceful tutorial that is specifically related to dictionaries. I suggest you to go and watch that tutorial video if you don't have an idea about dictionaries. I will put the link in the description for you, so you can actually go and watch that video. So now we have created our dictionary that is initialized by variable named datasets. Let's move on and actually use .item method to iterate towards key value pairs. So in dictionary, if you want to iterate on both values, the key and their respective value, you will use this .item method here. So we are using for loop for label and data in dataset .items. So here label will actually contain the label of the distribution or key, which in our case positive skew, negative skew, and no skew, and the data itself will contain the distribution. So now you know that. So our distribution is actually present in data. So we first of all we calculate the variance by initializing a variable named variance. Then I'm going to call the NumPy library and I'm going to use this method var, and within the square round brackets I'm going to pass my distribution one at a time through each iteration for using for loop. And for the skewness, I'm going to use the skew method of Panda library, Okay, and before we actually can put before I can actually use this method, I have to convert this NumPy array to actually Panda series. For this purpose, I'm using here PD series, and under the round brackets I'm passing the input argument data. So once the data distribution has been converted into Panda series, I can apply that skew method here, and once I have done that, the skewness is stored in this variable skewness. And after like calculating the variance and skewness for a particular distribution, I'm going to print the value by using print function, and within print functions I'm going to use the string method that actually allows us to embed variables in a string, and I'm going to print label their variance and skewness value one at a time. So now you understand this function of for loop and the values that are going to print. Let's go on and run that code of block of code for you. So now you can see that we have positive skewed whose variance is 1, and negative skew whose variance is 1, and then we have no skews whose variance is approximately equal to 1. Then for the positive skew we have skewness value equal to 2 positive value. Then for negative skew we have like skewness value is equal to -2. So we're indicating this is a negatively skewed data. And then for no skew we have actually a distribution is equal to skewness is equal to approximately equal to 0, very close to 0, which means that this data set has no skew or very minimum that can be discarded. So now once you have actually calculated the variance and skewness, let's move on and I graphically visualize the results. Okay, so it's a very hectic plot code. And it includes multiple steps that we use to generate that kind of plot. But don't worry, I'm going to stick here with you and I'm going to explain you step by step how we actually plotted that chart or graph plots here. So for brief introduction, you can actually see that we have like positively skewed data set that are also skewness values are also displayed. Then we have negatively skewed data set, and then we have no skewed data set. So how we actually plotted this plot here. So first of all, we are going to create the size of our image by using this method plot.figure and fig size. It takes input as tuple, and it defines height, which is equal to width, that is 15 inches, and the height is 5 inches. So this will correctly create the space for the plot. Now I'm going to use for loop here, and I'm going to use enumerate method. And if you don't have an idea about how enumerate methods work, I also have a detailed video on enumerates. I suggest you to go and watch that video. I will also put the link in the description for you so you can actually watch that video. So I'm going to use enumerate method, and basically it's quite a hectic topic actually to discuss about the whole execution of code here, but let me just go briefly over here. So we are first applying for loop, and we are using I that will actually have the index, and then we have also using labels and data in enumerate dataset.items. So basically we are iterating towards key value pair of the dictionary we have created earlier. Once I have done that, now I will create a subplot space by using this method subplot. 1 denotes the rows and 3 denotes the column, and I denotes the current position we are actually plotting the values at. Then I'm using Seaborn library and its function, its method hisplot, and I'm passing the current distribution, and then I'm passing the number of bins, and I'm also passing kernel density estimate is equal to 2. That will actually plot the kernel density estimate line. Then this line QWS is actually used, that takes a dictionary. It is for the line we are plotting here. So it defines the color of the line and also the line width here. Then finally I'm going to print the title. The title in our case will be printed dynamically because we are using fstring method that takes the label, which for example it's for positive skew, it will take the label as positive skewed and print its value. Then we have skew value here that we actually calculate the skewness value here, and we will plot its value. Okay, so then we have x-axis, y-axis labels, and then we are using this method tight layout, which actually helps us ensure that our graph doesn't overlap each other. Then we have this plot show method, which actually shows all those plots in a single output. So that's how was a brief introduction. There are a number of topics and there are a number of concepts that I have used in this specific plot function or code of plot. For enumerate, if you don't understand the concept of enumerate, I suggest you to go and watch that video. I will put the link in the description for you. And I also made a dedicated video regarding like how we can actually plot the histogram in Python. So I will also suggest you go and watch that video if you don't have an idea about how histograms are plotted in Python. Once I have let me just execute this block of code for you. So now you can see that I have also positively skewed data, negatively skewed data, and in the data set that has no skewness at all. So that's it for the skewness. Let's move on and briefly touch about variance. So variance is a measure of separateness or dispersion of a set of data point around its means. It gives us insights how much data individual data point deviate from the average value. I have actually made a dedicated video that is actually specifically dedicated to variance, how we can actually, what are the major units or what are the major aspects of variance and how we can actually calculate the variance of the data set by using those terminologies. I will put the link in the description for you so you can go and watch that video. That's it for now. I hope this tutorial has been helpful, and if you have any question regarding to skewness or any other aspect of Python programming, feel free to write down your problem or questions in the comment sections. I will be happy to help you out on that. Thank you for joining me, and soon I will be posting more videos on statistical analysis in Python. So I request you to subscribe to my channel, hit the notification bell icon button. So thank you for joining.